All right, something else we want to keep in mind. If I want this graph, and I want one that's parallel to it, I have the same slope. See, if I put 3/4 x plus 2, it's parallel to this one. Graph this one. Same slope means that they're parallel. Big idea. I can choose any value for x I want. I can pick 4, 8, 12, 16. I could pick 1 or 2 or 3, but it's going to give me a fraction. I like 4, 8, 12, 16. I like multiples of 4 because they're going to cancel out with this 4. The number I like the best is 0 because 3/4 times 0 plus 2 is always going to work out really nice, isn't it? Doesn't that just give me 0, 2? Somebody see if I put in 0 for x, I get 2? 0, 2 is located right there. Now if I want another point, I can count my slope to get it. I can go up 3 over 4. 1, 2, 3, and over 1, 2, 3, 4. I can go up 1, 2, 3, and over 1, 2, 3, 4, and I can get all the points I want without actually having to do the algebra or the arithmetic. Something I want you to keep in mind: if the slope is 3/4, we call this the change in y over the change in x. You sometimes heard it called rise over run. Notice that it's positive 3. That means I went up 1, 2, 3. And I went over 4. That's 1, 2, 3, 4 in the positive direction for x. Notice this is a positive 3 over a positive 4. Now if I wanted to, I could also write this as negative 3 over negative 4. Watch, I'm going to count it. I'm going to go from this point, and I'm going to go down 3. 1, 2, 3, and I'm going to go back 4. 1, 2, 3, 4. I'm still on a point. I can go down 3, 1, 2, 3, and back 1, 2, 3, 4, and I'm still on the line. You want to keep that in mind because a lot of times you have to count backwards to work these slopes. Now I just said these two lines are parallel, which means that they would not intersect. If I want a line that is perpendicular to these, it looks like this. It's at a right angle. And I want, can everybody see it's going to be a negative slope? It's going to go downhill. It's negative reciprocal. So negative 4/3 is going to be perpendicular. Try graphing this one. I'm going to put it in another color. Y equals negative 4/3 x. Let's make it minus 5. Graph that one. I'm going to graph it on the same graph. I graphed this one, the 3/4 x plus 2 right here. And I'm going to graph this one, the negative 4/3 x minus 5. And they should be perpendicular to one another. Negative reciprocal slopes are perpendicular. What's a nice point for this purple one? I like 0, negative 5. But personally, now you could pick any multiple of 3 and it would work out evenly. But I like 0, negative 5 just fine. It's called the y-intercept. And now from here, I'm going to go down 4 and over 3. That is 1, 2, 3, 4, and back 3. By the way, negative 4 over 3 is the same as positive 4 over negative 3. I can put the negative in the denominator and go up 4, 1, 2, 3, 4, and back 3. Now what you should notice about these is that they actually are at right angles to one another. We say that they're perpendicular. So if the slopes are equal, they're parallel. If the slopes are negative reciprocals, then they're perpendicular. We have two more kinds of equations that give people problems. One of the big ones, for some reason, everybody has trouble with this. Y equals 4. Seems like a simple one. This is a function, by the way. Y is always 4. It's very predictable. I know what happens no matter what I put in. It is a straight line. What I want you to do, and a lot of people get these mixed up. There's another one that looks kind of like this. What I like to do is put these points in. 0, 4. Pick a number. 1, 4, 8, 4. It doesn't matter what number you pick. Negative 10, 4. They will be on that line. Watch where I'm going to go. 0, 4. 1, 4. 8, 4 is way out here. Negative 10, 4 is way over here. But they're all on this horizontal line. This is a function. It passes the vertical line test. There is one y for every one x. In fact, there's one y for every x. Now the other one that people get confused with this is they like, if I say x equals negative 3, this is a vertical line. The best way to avoid having problems with this is to just go ahead and list some points. Negative 3, 0, negative 3, 5, negative 3, 8. You notice I don't have any idea what I'm going to get? Negative 3, negative 10. It doesn't matter. Any numbers that you want to put in here will work as long as x is always negative 3. Graph those. Get a nice vertical line. This purple line is the only kind of line that's not a function. All other lines are functions. Can you see why? You could even do a proof of that, couldn't you? Because all you have to show is that any line other than this, there's only one place it could ever cross, except for this one. That one doesn't work. Now, I'm going to tell you why people get these backwards. Very important. Check this out. What do you call this line right here? It has a name. This is the y-axis. The equation of the y-axis, the equation is x equals 0. Think about why that's true. Look at the points. Isn't this 0, 1? 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. Does everybody see that x equals 0 is the y-axis? And what do we call this line? The x-axis. And its equation is y equals 0. Do you see why people get these confused? It is really easy to mess this up. That's why I told you to write the points down.